In this video, we look at how to do project crashing. Project crashing is a way of reducing the overall duration of the project at a minimum cost. Here we have the normal time and then the related normal cost. And we also have crash time and the crash cost. The crash time is the absolute minimum duration this activity takes to complete. We cannot reduce it any further, and the crash cost to do that in 1 week is given here. Now, the first thing that we can do, let's say you want to crash this overall project. It's based on this network diagram we have for this project. It takes 15 weeks to complete, but let's say the project should be completed by 13 weeks. The due date is 13 weeks. So in order to do that, we have to crash some of the tasks. That is, we have to reduce the duration of the task. So project crashing is a way of reducing the overall duration of the project at a minimum cost. So first thing that we need to do here is find out the crash cost per week or per period. So this could be calculated by the crash cost using the formula given here, crash cost minus the normal cost divided by normal time minus crash time. So this gives the crash cost per period, in this case per week. And once you've done that, next thing is to figure out the critical path. So this project has just one critical path at this moment, so which is A, C, E, G, and H, because we have a slack of 0 for these tasks. Okay. So when we are crashing, we need to crash the task which is in the critical path so that you can reduce the overall project duration, because the critical path determines the overall project duration. So we have A is in critical path, B is not, C is a critical task, D is not, and E is 1, F is not, G is in critical path, and H is in critical path. So we need to reduce the or crash one of these tasks which is a critical task. So it should be A, C, D, G, E, A, C, E, G, and H. Now, to do this most cost effectively, we look for the activity which has the least crash cost per week. So we can take A, which can be crashed. So we can reduce the duration by 1 week at $750 per week. So that is the first choice. So let's do that. So let's go and reduce this by 1 week. So that in that case, this duration here should become 1. Now, you need to do this and then rework your critical path or rework your network diagram by doing the forward pass and the backward pass. So when we do that, you would realize that now there are 2 critical paths. Now D and B, which was previously non-critical task, has now become critical tasks. So our critical tasks have changed. So A is a critical task, B is 1, C, D, E, F is not, and others are, except for F, everything else is on critical path. So now we have, by reducing 1 week here, we have brought down the total duration of the project here to 14 weeks. Now we have to reduce 1 more week. So now we can go back and see. We cannot make any further changes because this is already 1 now. We have reduced it to 1 week. So this is not an option. So what we can do is look for other tasks that we can crash. So now, since we have two paths, okay, so we have a path B, D, G, and H is a critical path, and then A, C, E, G, and H is a critical path. There are two critical paths. So to reduce the overall project duration, you need to reduce both the path. Just reducing one will not reduce the overall project duration. So looking at the crash cost here, we can, I think the next lowest, now F is the least, but it's not on a critical, it's not a critical task. So we cannot reduce the project duration by reducing this. We can go for C, D, and E. Now, D is in one path, C and yeah, D is in one path, and then C and E is in one path. So we just need to reduce one of these two. Okay, so for example, we can reduce D and E to reduce this 14 to 13. So if we do that, we'll have an additional cost of 2,000. Now, another option that we have here is to reduce this, which is common to both the path. So both these path has a common node, which is G, which is common to both. We can reduce that by 1. Now that only costs 1,500, not 2,000 for both of these. So it is the best choice. So we can go and reduce G by 1. It's still reducible, so you can reduce it up to 2 weeks. So we just want to reduce it to 4 weeks to bring it to the required to complete the project by the due date, 13. So if we go and do that, so we would, if they change this to 4, and if you do the forward pass and backward pass, you'll see that the project duration goes down to 13 weeks. And then at an additional cost of 2,250. So 750 for reducing A from 2 to 1, and then 1,500 to reduce G from 5 weeks to 4 weeks. Yep, so we have the required, we have brought down, crashed the project to 13 weeks. All right, so that's a quick introduction to project crashing. Thank you.